This is question 14 from the 2022 GCSE Mathematics Higher Tier exam and tests our understanding of speed and time. If you find this video helpful, please consider leaving a like, a comment, sharing this video, and subscribing to our channel for more content like this. This is the first part of a two-part question. We've been given a speed-time graph and asked to estimate the gradient when t is equal to 2. The gradient of a curve at a point is found by drawing a tangent to the curve at that point. A tangent is a straight line that just touches the curve at the specific point defined by the x value, where the gradient is being calculated. The gradient of this tangent is a measure of how steep the curve is at that exact spot. Essentially, the tangent line represents the instantaneous direction of the curve at the point of tangency. In the context of this question, where the x-axis represents time and the y-axis represents speed, the gradient of the tangent is a measure of the acceleration at the point of tangency. Answering this question is a three-step process. First, we need to draw the tangent to the curve at the point on the curve where t is equal to 2. Then, we need to find two pairs of coordinates on the tangent before applying the rule for finding the gradient of a straight line and substituting corresponding x and y values. We've been told to estimate the gradient of the graph when t is equal to 2. By drawing a vertical line from the value 2 on the x-axis, we can locate the point of tangency. Then, using a ruler, we need to draw the tangent, making the angles between the curve and the ruler equal on both sides of the point. The tangent is drawn as a long line in order to identify suitable points on the line whose coordinates we can use to calculate the gradient. The two most obvious points are given by the coordinates 0, 0.8, and 4, 4.8. The gradient of a line is found by using the rule y2 minus y1 divided by x2 minus x1, where one of the points on the line is x1, y1, and the other is x2, y2. The 2 points we have found are 0, 0.8 and 4, 4.8, giving us a value of x1 equal to 0, x2 equal to 4, y1 equal to 0.8, and y2 equal to 4.8. Substituting these values into the rule gives us 4.8 minus 0.8 divided by 4 minus 0, which is equal to 4 divided by 4. And 4 divided by 4 is 1. So the gradient of the tangent we have drawn is equal to 1. For this question, an answer between 0.7 and 1.1 is considered acceptable. For more explanation and examples of calculating the gradient of a line, search our channel for gradient. This is the second part of a 2-part question. We've been asked to explain what the area under this speed-time graph represents. The area under a speed-time graph represents the total distance travelled by an object during that time interval. For a linear graph, we can use the rule where distance is the product of speed and time to calculate a value for distance. For curved graphs, the process is a bit more complicated. We can use different geometric formulas to estimate the area below portions of the graph. And at higher levels of maths, we can accurately calculate the area using integration. Answering this question successfully relies on our ability to construct a geometric tangent, calculate the gradient of a linear line, and an understanding of the physical relationship between speed, time, acceleration, and distance. Please follow us on Instagram, TikTok, and Threads for daily maths content.